40 Days of Chemistry, Part 5, and this time we're looking at 9.4.2, the first part of that. We're looking at ammonia, the chemical that changed the world. And this is ammonia's centenary, or the Haber process's centenary, because in 1913 the first industrial Haber plant opened. What we're going to look at is, what is ammonia used for? Now, ammonia itself is directly used as a cleaning product, and that's the main use of ammonia as itself that we know of. It was also used as a refrigerant gas. We know that from our studies of CFCs. At one stage it was also used as a rocket fuel. Ammonia, though, is a raw material for making other things. And first of all, using the Oswald process, it can be turned into nitric acid, and that then can be turned into explosives. The nitric acid can also be used to make nitrates, and nitrates can be used as fertilizers. The ammonia can be turned into urea using the Boss-Miser process, and that can be used as a fertilizer. And ammonia itself directly can be pumped into the ground as a fertilizer. So the main two products, or the main two uses of ammonia, are fertilizers and explosives, but it is also itself a cleaning product. Just be aware of the uses of ammonia. Nitrates in World War I. So why was ammonia so important, and why is it one of the most important chemicals in the world today? Well, pre-World War I, this is where the Haber process started. Pre-World War I, Germany used to import its nitrates from Chile. There's a special desert here in South America in Chile. It's one of the driest places in the world with a really high nitrate supply, and that was Germany's main source of nitrates. But to get from South America or from Chile over here to Germany, had to be shipped all the way around up into Germany, which was quite a long distance. And in early World War I, the British Allied Navy sunk Germany's Southern Naval Squadron and also blockaded the English Channel and North Sea. And if you think of Germany, Germany's here. It's got some seaports. This seaport here is not very useful to get in South America, but there's two access paths to South America, one through the North Sea and one through the English Channel. And the British fleet blockaded the North Sea and blockaded the English Channel. They also blockaded South America, and therefore Germany no longer had access to a nitrate supply. And because the nitrate supply was vital to making fertilizers and munitions, it was expected that Germany would have to surrender the war within a few months. However, around that same time, Haber and Bosch were developing their Haber process. Now, why is that so important? Well, nitrogen's everywhere. Nitrogen makes up 70% of the air, but nitrogen's a very hard molecule to do anything with because it's such an unreactive molecule. It's got a triple bond. It's very hard to break that bond and make compounds. And therefore, nitrogen has to be fixed before it can be made into something useful. And when we say fixed, it means that nitrogen in the air has to be turned into a nitrogen compound, which can then be used for other things. And that's what the Haber-Bosch process was all about. It was about converting that atmospheric nitrogen and combining it with hydrogen to make a useful nitrogen product, which is ammonia. And because they manufactured this process and made it industrial, Germany was able to keep supplying its population and army with food, and also kept supplying its army with munitions, and therefore the war was able to be prolonged and Germany could keep fighting the war. Now, ultimately, that had no impact on the outcome of the war. Germany still lost the war, and the prolonging of the war led to many, many, many deaths, but it had long-term impacts. That's why it's such an important process, the long-term impacts of the Haber process. So 100 years on, ammonia and the global food supply. Some pretty surprising statistics. 85% of all ammonia produced in the Haber process goes into fertilizer manufacture these days. The Haber process is estimated to support about 1/3 of the world's population. So 1/3 of the world's food supply comes directly from the fertilizers that come from the Haber process. And this blew me away, this fact. 1/2 of all the protein eaten by humans, so 1/2 of all the protein in your body, or 1/2 of all the nitrogen in your body, at one stage is in the form of ammonia from a Haber plant. So it's had a major positive impact on the global food supply and human health and nutrition. But as a counterpoint to that, you could also say that maybe it's contributed to overpopulation of the world, because without this Haber process, we wouldn't have overpopulation. And also it's led to an imbalance in the nitrogen cycle because they're putting so much extra nitrogen into the soil, and that's led to things potentially like excess nutrient in waterways, which we study in the water topic. But moving on, other impacts. It's estimated that the explosives manufactured from the Haber process, or from the ammonia to the nitric acid to the explosives, has resulted in the deaths of 100 to 150 million people in the conflicts and wars of the 20th century. So that's a pretty big negative. But on the positive side, all modern mining, and therefore all materials and processes we use today in our modern world, all energy, all appliances, comes from the products of mining, and therefore it's had a major impact on modern society, lifestyle and technology. And for its simple impact on the food supply alone, the Haber process is considered one of the greatest inventions of the 20th century. So moving on to the last section of this little video here, Fritz Haber, hero slash villain. A lot of misconceptions about Haber and what he did, but also his life's a bit of a tragedy as well. Let's have a look at some of the things in his life. This isn't strictly part of the syllabus, but it's come up in a few people's essays and notes, so we better get this dressed. So first of all, Haber was a German nationalist and fully supported Germany's war in World War I. And for the physicists here, it's a very similar story to Max Planck in World War I. He pioneered Germany's chemical or gas warfare program, and this is why he's infamous. He supervised the German army's use of chlorine gas, mustard gas, and phosgene gases in World War I. But be very aware, yes, he did that, but the gas warfare was not related to ammonia and not related to the Haber process at all. It was a completely separate part of research he did. He made the Haber process, that was one thing. Gas warfare was something else altogether. Now, some of the tragedy, his wife was so upset with his role in the gas warfare that she actually shot herself over the whole incident. He awarded the Nobel Prize in 1918 for his work on the Haber process, but because he was so hated and people wanted him tried as a war crime, hardly anyone showed up to the actual ceremony itself. Now, even more of the tragedy, himself, he was a Jew, and despite the fact that he was such a nationalist and worked so hard in World War I, when the Nazis came to power, he was ostracized and had to flee the country. And the last insight was that one of the chemicals that his company made, a chemical called Zyklon B, which is a pesticide, was one of the chemicals used by the Nazis to murder the Jews in concentration camps, including some of Haber's own relatives. So that's the story of Fritz Haber. It's quite a big tragedy, but then again, his legacy has lived on with us today with the global food supply and also the global mining.